Hello everyone. In today's class, we will be starting with chemical kinetics. And in chemical kinetics, we will be doing rate of a chemical reaction. So before going into the topic, let us first try to understand what is chemical kinetics all about. Remember that chemical kinetics is a branch of chemistry which deals with the study of the speeds or the rate of chemical reaction, the factors affecting the rate of the reaction, and the mechanism by which the reaction proceed. Okay, so chemical kinetics is that branch. First, what do we study? We study the speed or a rate of a chemical reaction. So how fast a reaction takes place. Okay, there are many class of reactions, as we know. Okay, different chemical reactions are classified into different categories depending upon whether they are fast, whether they are slow, or whether they take place in an average rate. Okay, so depending upon that, the different reaction are classified as very fast reactions, slow reactions, okay, very slow reactions. So the question is, how do we decide this rate? How do we find out the speed of a reaction? So whenever we say speed of a reaction, it always with respect to time. So like whenever we say speed of a particular object, moving object, it is always the distance which it covers per unit time. So in chemical reaction, what is changing per unit time, that is what we actually calculate to find out the rate or a speed. So remember that in chemical reaction, what do we take with respect to time? What is changing with respect to time is nothing but the concentration of reactant or product. It was always found out that in a chemical reaction, reactant react to give you product. So the chemical reactant always reacts to give you a product. So the concentration of the chemical reactant, as it goes on decreasing, the concentration of the product will go on increasing. Okay, so remember that the rate at which the concentration of the reactant decreases and the rate at which the concentration of the product increases is always same. The more the reactant will decrease, the more the product will increase. So that is what we'll be trying to understand when we take the rate of reaction. So that is the first thing we deal in chemical kinetics. The second thing which we understand in chemical kinetics is about the factors. What is deciding this rate? What decides this rate? Can we increase the rate of a reaction? Can we make a reaction faster? Can we make a reaction slow? Yes, it is possible. So there are various factors which relates or which dictates the rate of a chemical reaction. Some of which are concentration, temperature, catalyst. So these are few of the factors which we'll be covering in chemical kinetics, and the mechanism by which the reaction takes place, how a reaction proceeds. Okay, so all these things we'll be trying to deal in chemical kinetics. So in today's class, we'll be trying to understand what is rate of a reaction. So as I have told you, whenever we talk about the rate of a reaction, if we want to define it, the rate of a chemical reaction may be defined as the change in concentration of any one of the reactant or any of the product per unit time. So what is it? It is nothing but the rate of a chemical reaction. Whenever we talk about rate of a chemical reaction, it is nothing but the change in concentration. Either it may increase or it may decrease. As I have told you, if a reactant goes to a product, the concentration of the reactant will always decrease. The amount of reactant will always decrease. It will decompose, it will react, and the amount of product will always form. It will go on increasing. And how much a reactant will decrease, that much a product will form. So it is nothing but the rate at which the reactant or product is forming, or the change in concentration of the reactant or product per unit time. Okay, it is similar to how we measure the speed of a moving object. It is nothing but how much distance it is covering per unit time. Change in distance per unit time is nothing but we call it speed. In the very same way, change in concentration of reactant or a product, okay, per unit time is nothing but the rate of a chemical reaction or a speed of a chemical reaction. So rate of a chemical reaction, if I want to express it, so what is it? It is change in concentration of a reactant or a product by time interval. In how much time interval, how much concentration of a reactant or a product is changing is nothing but the rate. Okay. So now the question is, what will be the unit of the rate? The unit of the rate will be moles per liter per second. I hope you can understand that. Change in concentration. Here the concentration which we are taking is molar concentration, molarity. Okay, so it is moles per liter, and obviously with respect to time. So time I can take in per second or I can take in per minute. So that depends upon the calculation. So the unit of rate of reaction is moles per liter per second, okay, or moles per liter per minute. Okay. So now this rate of reaction is basically, we have classified into two categories. The first one, we call it average rate of a reaction. So whenever anyone say average rate of reaction, what do we basically mean? It is the change of concentration of any one reactant or product, again, per unit time over a specified interval of time. Okay, where the time interval is specified. Okay, so over the specified interval of time, maybe 1 minute, 10 minutes, okay, 30 seconds, okay, 2 minutes, 3 minutes, in that much time, how much of the concentration of the reactant or the product is changing, that is nothing but average rate of a reaction. So whenever anyone say average rate of a reaction, it is nothing but the change in concentration of reactant or a product per unit time. The definition remains the same, but over a specified interval of time. We call it average rate of reaction. Now, average rate of reaction. So how we can write? Again, it is the same. Change in concentration of a reactant or a product by time interval. The only thing is that the time interval is a specified time interval. That's all. Okay. So let us try to take a reaction to try to get a mathematical expression. So let us consider a reaction of the type A to B. Let's say a reactant A is converting to a reactant or a product B. So in such case, how do we understand or how do we get the expression of average rate of reaction? So whenever anyone will tell me to write the expression of the rate of reaction, what I'll write is decrease of concentration of A by time interval. Okay. I can express it in terms of reactant. I can express it in the terms of product. So here I am trying to express in terms of reactant. As I have told you, the concentration of the reactant will always decrease with time. As the time goes on, the concentration of reactant will always decrease. It will go on reacting. It will go on decomposing. As a result, it will always decrease. Okay. So how much it is decreasing in how much time is nothing but average rate of reaction with respect to reactant. Okay. Or what I can write is minus. So remember that here minus does not mean that the value is negative. Okay. So don't take that minus as negative value of rate. Rate cannot be negative. What it suggests us is, or what it indicates is that the concentration of the reactant is decreasing with time. So this negative sign tells us that the concentration of reactant decreases with time. Okay. And delta denotes the change in concentration, and third bracket A denotes the molar concentration, how much concentration is changing with respect to delta T. That is how much change in time. What is the time interval? The same thing can be written as in terms of product. So now since we know that the concentration of product will increase, so it will be increase in concentration of B. Okay, because how much concentration of A will decrease, that much concentration of B will increase in that same interval of time. So the magnitude will remain same. Remember that. The only difference is one is increasing, another one is decreasing. Not the rate, but the concentration. In one case, the concentration of reactant is decreasing. In another case, concentration of product is increasing. That is the only difference. Otherwise, the magnitude of rate exactly remains the same. Okay, so what I can write is plus delta B by delta T. Okay, delta again tells us the change. Okay, and third bracket B tells me that it's molar concentration by how much time interval, which will remain same. Okay, so that is how actually we can mathematically interpret it. Now let us try to take a more general type of reaction where a reaction is taking place between A plus B and giving you C and D. So in such case, what do we do? So how to write the average rate of a reaction? So the average rate of the reaction we can write in terms of A. If you'll give me only reactant A, if you'll give me the change in concentration of A, how I can write? Since it is a reactant, so first I'll introduce a negative sign, change in A, change in concentration of A by the time interval. In terms of B, how to write? Minus delta B by delta T. In terms of C, since it is a product, so I'm introducing a positive sign, which indicates that the concentration of product will increase. Concentration of C will increase with time. So delta C by delta T and concentration of D by delta T. So that is how actually we can understand that how to express the rate of a reaction. Okay. Like for example, let's say if you get this kind of expression, okay, or this kind of equation, PCl5 gives you PCl3 plus Cl2. And if they tell you to write the rate of a reaction, how do you write the rate of reaction? So average rate of reaction minus. So why I'm introducing minus? Again, I'm telling you because this is the reactant whose concentration will decrease with time. So negative change in concentration of the reactant. What is that? PCl5 with time interval. In how much time interval, that we don't know. So same thing. If now, since this is a product, so I am introducing a positive sign, delta PCl3 by delta T. And the next one is again a product, that is plus delta Cl2 by delta T. So whether I find with respect to PCl3, whether I find with respect to Cl2, or whether I find with respect to PCl5, I will get the same answer. Because how much one will increase, the other one will increase by the same amount. Okay. Let us try to take a more general reaction of the type. Usually we have a reaction where we have number of moles, or what we call as stoichiometric coefficients. So if we have stoichiometric coefficient or number of moles, in such cases, how do we understand the rate expression? So let's say we have a reaction of the type A of A moles of A will give you B moles of plus B moles of B is giving you C moles of C and D moles of D. So in such case, how to write the rate expression? So the average rate of reaction, and see carefully over here, we are dividing by the stoichiometric coefficient. So always remember that whenever you have stoichiometric coefficient in a chemical reaction, it is always divided. Okay, it is always, the rate is always divided by it. Okay, so it will be again minus 1 by A delta A by delta T. For B, it will be 1 minus, again, it is a reactant, 1 by B, that is the stoichiometric coefficient, delta B by delta T, plus 1 by C, delta C by delta T, and plus 1 by D, delta D by delta T. Now try to understand, okay, why do we actually divide it by a particular stoichiometric coefficient? If I take this particular reaction, okay, or let me take a general reaction only. For example, let us take this, okay, N2 3H2 2NH3. So if you take this formation of ammonia, okay, what you can see is 1 mole of ammonia. If I take a particular instant of time, okay, where 1 mole of ammonia will react, okay, at a particular instant or a particular time interval where 1 mole of ammonia is reacting or 1 mole of nitrogen is reacting. So if at that particular time 1 mole of nitrogen will react, so how many moles of hydrogen will form? 3 moles. And how many moles of ammonia will form? 2 moles. So are they equal? Obviously not. So in the same interval of time, 1 mole of nitrogen reacts and 3 mole of hydrogen reacts in the same interval of time to give you 2 times of ammonia. So in the same time interval, 1 time of nitrogen reacts with 3 parts of hydrogen to give you 2 parts of ammonia. So what is happening is the change in concentration of the reactant and product is not same. That usually we face when we have stoichiometric coefficient and when the stoichiometric coefficient are different, and usually it will be different. So try to understand in such cases at a particular interval of time, we can clearly see that if 1 part of nitrogen will react, 3 part of hydrogen will react, and 2 part of ammonia will form. So in such case, what you do? So to make them equalize, if I divide the rate over here, it's just 1. So the rate I am writing as minus delta N2 by delta T. Okay. But over here, it is 3 times of nitrogen. Is it not? 3 times. The rate will be 3 times of it. The concentration will change 3 times for hydrogen. So I don't want it to change 3 times. It will not be equal. We are writing equal. So how to make it equal? If it is changing 3 times, we will divide it by 3. So if we divide it by 3, then what will happen? The concentration, or it will change 1 time now. So this and this will remain same. The same thing, this is changing 2 times. So if I divide it by 2, again, it will become the same. So that is why actually we divide by stoichiometric coefficient. Okay. Since in such cases, okay, where we have stoichiometric coefficient or number of moles, the same time or the same part of the molecule is not reacting. Okay, in our previous case, 1 mole of a reactant was giving you 1 mole of another reactant was reacting to give you 1 mole of product and another 1 mole of product. All was 1 mole. So over here, 1 mole of nitrogen will react with 3 mole of hydrogen to give you 2 moles of ammonia, which is not same. So in such cases, obviously, to make it same, to make the rate same, what we need to do is divide by the stoichiometric coefficient. So always remember that. Okay. Now, the second type, that's what I've told you, that the rate of reaction is expressed in 2 ways. One is average rate of reaction. So what we have learned in average rate of reaction is, it is basically the rate of a reaction only, but in a specified time interval. Okay. What is instantaneous rate of a reaction? By the name itself, instantaneous, at a particular instant. So that means the time interval is very, very small. So try to understand, if the time interval is very small, the change in concentration will also be very small. Okay. So how do we define it? The rate of change of concentration of any one of the reactant or product at a particular instant of time is called the instantaneous rate of a given reaction at that instant of time. So what we are trying to do is, we are trying to make our time interval very, very small, as a result of which the change of concentration also tends to become very less. Okay. So if we try to find out the rate at a particular instant of time, then that becomes instantaneous rate of reaction. Like instantaneous rate of reaction is given by dx by dt. So we don't use a delta, we use a d, okay, or a del. So what is dx by dt? So where dx is a small change in concentration of the reactant or product that depends in a small interval of time dt. So obviously, when I make the time interval very less, the change in concentration will also be less. Such way of expressing the rate of a chemical reaction is nothing but instantaneous rate of a reaction. The other concept exactly remains the same. Okay, the reactant will decrease, the product will increase. How to express the rate of reaction also remains the same. The only change is the notation and the concept that the time interval is very small. It is at a particular instant, and in average you have a specified time interval. Okay, like if I take the same reaction again, whole concept remains same. We have to divide by the stoichiometric coefficient. The only thing is that we change this notation. Okay, so it will be dA by dt, it will be dV by dt. Okay, and it will be dC by dt, and it will be d of d by dt. Okay. For example, like if I take the same case again, okay, and try to understand how to understand the average instantaneous, sorry, there is a mistake over there. It has to be instantaneous rate of reaction, not average. So instantaneous rate of reaction. So it is again given by minus dN2 by dt. Okay, minus 1 by 3. Again, same thing. Stoichiometric coefficient, we have to divide dH2 by dt, and plus, obviously it is a product, 1 by 2 dNH3 by dt. Okay, please make a change over here. It has to be instantaneous rate of reaction, not average. Okay, so that is how we can understand what is the instantaneous rate, what is average rate, and how to understand the concept and how to write the rate of a particular reaction, the expression of a particular reaction. Okay, the rate expression. So let us try to take a problem. Okay, for the reaction twice A plus B gives you 3C plus D, which one of the following does not express the rate of a reaction? So does not express. Okay. So in such cases, what you do first, let us see the option. So these are the three options given. So whenever you encounter such type of problem, the simplest way of doing is first you write down the rate expression. So how to write the rate of reaction? So rate of reaction will be minus half of dA by dt. I hope you understand that. Okay. Minus dB by dt. Okay. Because these are reactant. Then plus 1 by 3 dC by dt. And obviously plus dd of dt. Okay. Now, if you try to understand this, okay, so this is the exact rate of a reaction or the expression of the rate of reaction. Now you compare, okay, minus dB by dt. Obviously, we can express as minus dB by dt. dd by dt, yes, we can express it. Minus half dA by dt. Yes, we can express it minus half dA by dt. And if you see option D, minus 1 by 3 dC by dt, which is wrong because C is a product. I cannot write minus, it will increase. So it will be plus 1 by 3 dC by dt. So the correct answer in our case is option D. Option D will not express the rate of this particular reaction, while the other three will do. Okay. So in simple way to express the or to solve such type of problem. Let us try to take another one. Okay. For the reaction, okay, N2 plus 3H2 gives you 2NH3. dNH3 dt, okay, the rate of change of NH3 is given, okay, which is 2 into 10 to the power minus 4 moles per liter per second. The value of dH2 dt, okay, the change in concentration or change, sorry, the rate of change of concentration of H2. So that is what we want to find. So the option are this. So we have to relate NH3 with DH2. Okay, so H2 and NH3 we have to relate. So first, again, we'll be trying to do the same thing. We'll try to write the rate expression. So the rate of the reaction will be minus dN2 by dt. Okay, minus 1 by 3 dH2 by dt, and plus 1 by 2 dNH3 by dt. So that is the rate expression. What we need to relate is the H2 with NH3. This is not given to us. So we'll try to relate this. So this is equal to this from the expression. So therefore, minus 1 by 3 dH2 by dt is equal to plus 1 by 2 dNH3 by dt from this. Okay. So now I have to find dH2 by dt. dNH3 by dt is given. So what is dH2 by dt? Will be equal to 3. If it comes to the numerator, it will be 3 by 2 dNH3 by dt. Now dNH3 by dt is given to us, which will be equal to 3 by 2 into 10 to the power minus 4. So if I just simplify this, 2 and 2 goes off. So it will be 3 into 10 to the power minus 4 moles per liter per second. So that is how actually such type of problems are solved. Okay. Let me try to take one more. In the reaction, so this is the reaction given, okay, BrO32 minus aqueous plus 5Br minus aqueous, 6H plus gives you 3Br2 in liquid state plus 3H2O liquid. The rate of appearance, okay, formation, that is what we mean, okay, the rate of appearance. See, Br2 will appear, right, form, okay. As the reaction goes on, the more bromine will be formed. So that is what we call as rate of appearance. How fast the product is forming. So rate of appearance will always be for product, and rate of disappearance will always be for reactant. Okay, is related to rate of disappearance of bromide ion as following. Okay, so these are the 4 options they have given. So now our problem is to find out which one is correct. So again, the same thing. First, we'll write the rate expression of this. Okay, always whenever you encounter such type of problem, always first try to find out the rate expression. So what will be the rate expression? So this equation is this. So for this equation, rate of reaction will be plus dBrO32 minus by dt, okay, plus 1 by 5, okay, 5 is there, dBr minus by dt, plus 1 by 6 dH plus by dt will be equal to minus, this is, sorry, there is a slight mistake over here. This has to be minus dBr03 by dt, since it is reactant, minus, not the plus, 1 by 5 dBr minus by dt, and equal to minus 1 by 6 dH plus by dt. Okay, so that will be, all this will be minus instead of plus, and this will be plus. Okay, plus 1 by 3 dBr2 by dt. This has to be plus because this is the product, and plus, okay, obviously this is correct, 1 by 3 dH2O by dt. Now we have to relate this. So how we can relate it? So if you try to relate this, okay, with this, okay, that is what we have to relate, right? So bromine with bromide, if I try to relate it, this is what I'll be getting. dBr to dt will be equal to, so you just relate this, this will be minus, and obviously this will be plus. Okay, so if I relate this, it will be minus 3 by 5 dBr minus by dt. Okay, so that is how actually we solve this kind of problems based on chemical kinetics. So that is what we mean by rate of a chemical reaction. So whenever we say rate of a chemical reaction, what basically we understand is the change in concentration of reactant or product per unit time. It can be expressed in two ways, that is average rate of a reaction and instantaneous rate of a reaction. Okay, so average rate of a reaction is again change of concentration, but in a specified interval of time, whereas instantaneous rate of reaction is the change in the concentration of reactant or product, but in a particular instant of time. Okay, only the expression changes, the way we denote the change changes, otherwise the whole concept remains the same. And how to solve the problem based on the rate of a reaction, we have seen that. Okay, so that is how we can understand the rate of a reaction in chemical kinetics.